Have you ever wondered why the sky appears blue? Why does the sun turn red at sunrise and sunset? Why are the clouds white? And why does the sky appear completely black to an astronaut in space? These may seem like four completely different questions. But what if I told you there is one simple phenomenon that explains them all? Scattering of light. One phenomenon, so many mysteries. When sunlight enters the Earth's atmosphere, it encounters countless tiny particles and air molecules. These particles interact with the light. The molecules absorb energy from the incident light and re-emit it in different directions. This phenomenon is called scattering of light. But here's the important part. All colors of light are not scattered equally. And that is where the real story begins. The atmosphere does not scatter every color of sunlight equally. Some colors are scattered much more than others. The shorter the wavelength of light, the more strongly it is scattered. And the longer the wavelength, the less it is scattered. In visible light, violet has the shortest wavelength, while red has the longest. So violet is scattered the most and red is scattered the least. In fact, violet light is scattered nearly 16 times more than red light. Now, there is a scientific rule behind this. You don't need to be frightened by this formula. It simply tells us one important thing. A small decrease in wavelength can cause a very large increase in scattering. And this one simple idea will explain why the sky is blue, why the sun appears red at sunrise and sunset, and even why red is used for danger signals. So let's see how it works. As sunlight passes through the atmosphere, the shorter wavelength, blue and violet components are scattered much more strongly than the longer wavelength, red component. The scattered blue light travels in different directions. Some of this scattered light enters our eyes. Therefore, when we look at the sky away from the direction of the sun, we see predominantly scattered blue light. So remember this for your exam. The sky appears blue because blue light is scattered much more than red light by the molecules of the atmosphere. Why does the sun appear red at sunrise and sunset? At sunrise and sunset, sunlight has to travel through a much greater thickness of the Earth's atmosphere before reaching us. During this long journey, the shorter wavelength blue and violet light is scattered away to a much greater extent. Much of it is lost from the direct sunlight reaching our eyes. But red light has the longest wavelength, so it undergoes the least scattering and travels through the atmosphere with comparatively less loss. Therefore, the direct sunlight reaching our eyes is rich in red light. And that is why the sun and the region around it appears red at sunrise and sunset. Now let's change the time of day. What happens when the sun is directly overhead? At noon, the sun is almost directly above our head. So sunlight has to travel through the atmosphere for the shortest distance before reaching us. And because this path is so short, there is not much scattering of any particular color of light. So the different colors present in sunlight reach us together. And when all these colors reach our eyes together, we see white light. So the exam answer is simple. At noon, the sun is directly overhead. We receive sunlight after it has traveled the shortest distance through the atmosphere without much scattering of any particular color. Hence, the sky appears white. So here's we have seen why the sky appears white at noon. But now let's move beyond Earth and ask a fascinating question. Why does the sky appear black in space? Now imagine removing the atmosphere completely. There are no air molecules to scatter sunlight. Therefore, light reaching the observer comes mainly directly from the sun. In directions away from the sun, there is essentially no scattered sunlight entering the eyes. So the sky appears black. This is why an astronaut above the Earth's atmosphere sees a black sky even when the sun is shining. And yet, the Earth itself can appear blue because its atmosphere scatters blue light. Clouds contain tiny water droplets, ice particles, and other particles that are much larger than the molecules responsible for atmospheric scattering. These larger particles scatter the different wavelengths of visible white light much more nearly equally. Since all the colors are scattered together, the combined scattering light appears white. Red has the longest wavelength in the visible spectrum. Therefore, it is scattered the least by the atmosphere. It can travel a greater distance without becoming as weak as light of shorter wavelengths. Therefore, red light can be seen from farther away. That is why red is used for danger signals and warning lights. Now let's see if you can answer these without looking at your notes. Why is the sky blue? Because blue light of shorter wavelength is scattered much more by the molecules of the atmosphere. Question 2. Why does the sun appear red at sunrise and sunset? Because sunlight travels through a longer atmospheric path, causing the shorter wavelength blue light to be scattered away, while the longer wavelength red light reaches our eyes. Question number 3. Why does the sky appear black on the moon? Because the moon has no atmosphere, so there is no scattering of sunlight. Why are clouds white? Because the larger water droplets and particles in cloud scatter all colors of visible light nearly equally. Why is red used for danger signals? Because red has the longest wavelength and is scattered the least. So it can be seen from a greater distance. So the next time you look at a blue sky, watch a red sunset, see a white cloud, or notice a red warning signal. Remember, they are all telling the same story, the story of scattering of light. One concept, many phenomena, scattering of light. Understand it, don't just memorize it.